Hi, I'm Alan Ross, and I'm the Managing Director for Editorial Content at APC Media. Our webinar today is I'm moderating, and it is hosted by Vaisala, and some people say Vaisala, and I don't know which way you. I think you've told me both ways work, right, Senya? As
Yes,
long as we say
Vaisala.
the word Vaisala. And my guests are Senya Leovo, who has done a couple of articles for us at APC Media, and we just no, Senya started. There we go. And Lee Doyle, and Lee is out of their Boston office. So we're well covered with Europe and the United States, which also covers Canada, Latin America, and a lot of other places. When I thought about this, the 5 critical considerations for getting the most out of your online DGA, the exciting part for me was I love DGA. It's been how I was introduced to the transformer industry 20 years ago. So I'm, as much as any of the other people on here, I'm pretty excited to find out what are the 5 critical considerations, because I probably wasn't making them correct. So Senya, why don't you start, and we'll get to all 5 of them. Thank you for being here, and all of the participants. Thank you for joining us.
Thanks, Alan.
Thank you, Alan, for having us today here. Yes, critical considerations for getting most out of your online DGA. We are not going into kind of
Hey,
a very...
Senya, you're going to want to swap the screens.
Sorry. Sorry. Okay. So you have the presenter's view now.
It's presenters here, yeah.
Okay, sorry. Display settings, duplicate. Here we go.
Perfect.
Okay, sorry for that. So I'm not going into very technical details, but I think our main message here is to go through these 5 items and give you some tips and ideas how to consider this. So first of all, how to select the transformer which to monitors. Many utilities have a lot of large fleet, and it's obviously not realistic to have wide online monitoring for each and all of those. So let's talk about that a little bit. Then the second part is the location, how to set up the monitor. It's not only the monitor itself. There are many things to consider. Utilization of the data, how to get access on the data. Is it a SCADA integration or other system integration? Very important part. And then obviously alarm limits, how to set up those, and at the end the data interpretation. So I'll start shortly here to discuss like which transformers to have the online monitoring. First of all, I guess where to start is to consider through the whole fleet is that which transformers benefit most from the continuous monitoring and gives the best value for the utility, considering the asset reliability and protection. So one way to look at it is the transformer criticality. It's not necessarily the biggest transformers. Depends on whether there is a redundancy, how the grid is made, if it's question of transmission or distribution. Do you apply this N-1 policy, or is it so that there is no redundancy, and that's why some transformers are much more critical than the others. And the other way to look at this is to see the fleet and consider if there are a set of a group of transformers in a fleet that has a relatively similar use, loading, ambient conditions, etc., even about the same age. then to look at how these transformers relate to each other. And in this example table, what I've put here on this slide is 6 relatively similar transformers. Sometimes could be even from same design, same manufacturer at the same time, having very similar history, and you would expect the gases in these 6 transformers to be pretty similar. But now when we look at this table, the transformer 42, we can clearly see that some of the hydrocarbons are very much higher on in this one than the others. So this could be one potential candidate for monitoring, because it obviously has a rather abnormal gas formation compared to the others. So at the end, we could think about this monitoring, especially when there is a bigger fleet of transformers, hundreds or even thousands of transformers. It's not financially reasonable to have every transformer having an online monitoring, at least not on the multicast. So to look at the risk assessment, what is the failure probability of transformers and what are the consequences on that? So maybe some food for thought in here. Any adds from your side, Lee?
Yeah, so if we kind of bring this into, I guess, more practical applications, right? So here you can see these are 2 transformers that two different customers that we've looked at monitoring, and they're critical for different reasons. So you have, on the left, you have a 230 kV auto transformer, important for the local transmission grid, and then you have a 69 kV distribution transformer on the right side that's important for local homes and businesses. And so that's when when customers ask is what is a transformer that I should monitor? It's not a simple answer of as you already mentioned of its type or even size. It's really these 3 questions that I've laid out here are things that we should definitely consider. Is do you have a backup? Do you have a spare? Can you offload this transformer? Is it in a place where if there was an issue, somebody could get hurt? Is another important one. And then what is if this is of concern, what is the replacement plan that you want to undertake? And is the equipment and the personnel available to undertake that replacement? So it's as we'll talk about, some of this stuff is definitely going to come down to the individual transformer and the individual application. That's just as important as, say, size or value.
Sonia, I've got a question. If you can go back one slide, can you go back to the original? Yeah, stay there. So right now, one of the, as you all are talking about this, one of the difficult considerations is aging transformers that were projected to be replaced, but because the transformer supply market is way behind the demand market, now you have another factor in there is, hey, we thought we would replace this next year and we don't have another one. It's coming in 5 years. Literally, that's happening. That's one issue. The other one is multi-gas versus single gas. Like if you did hydrogen temp, is it my understanding that hydrogen is the first gas to show up, but it's also the first one to dissipate? So you can't really rely on it. But if you put a check engine light, a hydrogen monitor with maybe temp something else, pretty inexpensive, you can put more of them on there. And then the critical ones like you're showing here, you can just see the gases from, I assume this is a sampling, annual sampling, maybe even a quarterly sampling of the gases. Is that what, and for that one, you would put a multi-gas. Talk a little bit about not just when to monitor, which transformer, what monitoring system you put on it.
That is a very good question, and a lot of discussed when talking with people from utilities. in general, hydrogen is considered as a early warning device, not enabling any diagnostics. And that is true in most of the cases. However, what I've noticed and discussed with many other people who are working with DGA, there is a group of faults and these thermal faults. Like in this case, these units here are GSUs, so heavily loaded, and there may be thermal faults which actually do not produce significant amount or even any hydrogen really, or the
Yeah.
little hydrogen that is formed disappears somewhere. So in generation step up transformers, the big ones, I usually always recommend to have multicast to be able to track all different fault types. Then on smaller ones or less critical ones, yes. When having a big fleet, it's not realistic to have multicast in all of them.
Okay. So if you put a plan together and say, I'm going to do a combination of multi-gas monitors and check engine like hydrogen monitors, you can actually leverage your budget and maybe, if anything, if you have 10 transformers in the same class, if anything, it'll tell you which one to look at first because the hydrogen check engine light goes off, which you then can do a sample and make some decisions there. Okay, that's
it's
an interesting thing that's happening right
case
now.
by case, yeah.
Yeah. Okay, perfect. Thank you. And by the way, people who are on here, if you have a question about the consideration, like I had on first consideration, go ahead and ask it. Put it in the chat, and I will get that question, and we'll try to answer it when we're talking about that consideration. If not, at the end we will have all of the questions, and we will answer them.
Okay, so let's move on. Once you have decided that, okay, these transformers will have the monitoring, the next thing to do is to really do a proper planning. Look at the site, consider everything there. How to access the oil, how to get the oil to the monitor, where to put the monitor, and so on. Really do proper planning, because it's always easier to do the planning on paper than there on site once you have all the bits and pieces spread around the transformer. So I have collected here just a few things. Like for example, where to locate the monitor. And now it depends a lot, like which type of a monitor. This one here, it's a multicast DGA monitor. If it's a single gas monitor, then the location is totally different. It's somewhere on the cooling circulation, for example. But now in this this example here, I have taken a few things here as the factors. Is like, for example, what is the climate conditions? Like if you can see for the of the photo, we have snow here, so it's
Finland.
Arctic Arctic conditions. So this specific site, they had during a winter time something like, sorry guys, now I'm in Celsius scale, so -32, I guess, was the lowest temperature. Bottom oil temperature in this transformer transmission transformer was -15 degrees C. So definitely what we need is trace heating on the oil pipes. We need thermal insulation. But before we get into that, we have to have a look where we get the access to the oil. So here is an oil valve, and we have or the customer has taken the pipes to the monitor from there. And and also very important thing, the monitor is really carefully, securely attached to the, in this case, the concrete slab, so bolted there. we have to think about when measuring DGA gases, we are measuring really small concentrations, kind of a trace amount of gases. Oil pipe quality may have extreme effect, and it's very important. And in our recommendations, it's always to use metal pipes, never hydraulic hoses, for example, because these hoses have plasticizers, additives that are evaporating. They can get into the oil, get into the monitor, and cause false alarms there. Environmental factors I already mentioned: temperatures, solar radiation, rain, wind, salt, mist, offshore applications, and so. Try to have the conditions clean and dry during the install. Protect the device and also the people doing the work. Over to you, Lee.
Yeah, thanks, Senja. To build off of that, I think it's what I found to be really important is to try and keep the monitor as close to the transformer as possible. So having the flexibility in your monitor that you could possibly mount it to the transformer, or if you have some sort of custom mounting solution, if it can adapt to that, is really ideal. And the reason you want to do that is obviously you can reduce your costs, maybe not significantly, but metals in particular are going up in cost, so you can reduce your cost there. But it comes down to also the operation of the monitor, right? When we're talking about monitoring a transformer, obviously there's a lot of oil. I mean, thousands of gallons, right, inside of there, and we want to make sure that when your monitor is operating, that the sample of oil is representative of the current conditions inside the transformer. So keeping those runs as short as possible is really important, and that extends to the electrical and the communications that you'll need to put in place as well.
Is it possible to have one monitor or a system that could actually monitor multiple transformers at the same time, or not?
There are suppliers out there that do offer, let's say, I think they market it as multi-tank systems.
Okay.
That are available. We don't generally recommend that type of setup, just because of contamination, cross-contamination issues you could run into. But
Yeah.
it is offered.
Okay. But if you don't recommend it, it's offered but not recommended. Okay, great. Because these are all the decisions that somebody is having to make. One of the other things about the selection that I don't want you to go back a slide, Senja, but another one is how good is the people monitoring this? Like if it's at a utility and the 5 people that know anything about DGA have retired between today and 5 years ago. Now you've got a relatively young new engineer. He's never been to a transformer committee meeting. She has never really, I mean, they just got handed this new role within the utility. And if they're not that attuned to it or not that experienced, that's another consideration for monitoring. And the diagnostics, as you said, is correct. So looking at the people who are staffed to manage these things is an important consideration too, correct?
I think, yeah, it's definitely like how you said, Alan. I think very important thing is in this monitoring is to have a continuous discussion with the customers, with the utilities, and that is a way how we can help them to kind of start their monitoring scheme.
Okay.
And policy. I think it's within this industry. I think every everybody working throughout the whole value chain in electric power industry, I think it's very, very important that we share information and share experiences, like what they do in IEEE and SECRE, for example.
Right. Excellent. Yeah. Sorry, I'll keep interrupting. Oh, number 3.
No worries, no worries. We are here to discuss, aren't we?
Yes.
So the third part is that now we have the monitor there on site and installed and even up and running, and we come to a question that how to utilize the data, how to make it available. This is one example what I have here on the screen. It's actually based on one of our customers setup, so that in that case the transformer is here, the monitor is taking oil every hour or so. They also continue having a lab DGA, so they do take samples still, not so frequently as they used to do earlier. This is a GSU again, and then time to time they compare the lab and the monitor reading. But when looking at the now the online monitoring part is how they have done it. Here is a digital communication through fiber optics. They have separate fleet management. This is not always available, but let's say the more advanced and more used, the utilities who are more used to do online monitoring, they tend to have a separate fleet management system, because they will get so much data. They don't want to get the additional data here on the SCADA to get slow it down. So all the measured gas data goes here, and then the monitor is hardwired, usually with just copper wires, the relays to the SCADA system of the utility. And important part here is the people, because monitoring itself doesn't fix anything. It's nice, but the monitors, they only raise the flag that something is ongoing, but they don't tell you what to do, when to do. So when you do this or plan to start to use online monitoring, I think it's as important at the same time to decide what is your process if there is a gas alarm. And what many people in utilities, they tell me that when the SCADA system gets an alarm, the people in the operator room, they don't know about these transformers. They have the whole grid there in front of their faces, and then they say this red light blinking there. So if there is no process to go further from that, what may happen is that they just acknowledge the alarm, mute it, and that's it. If there is a proper process in place in such case, when there is an alarm, the operators notice that okay, there is this. They know exactly who to call. In this case, the SMEs, the experts on transformers, who then go back to the fleet management to have a look which transformer it is, which gases are there, and then they can give a better instructions on further on what to do for the maintenance. Is it taking a sample or is it something else?
Quick question before you move on to Lee. That SME, and this is specifically to Vaisala, is do you all have a subject matter expert to support customers who don't have it on staff?
We do support the customers, but we don't have like a service for that. But it's our standard communication between the customers and us. But it's not like
So somebody
offered
calls up
service.
in a panic and says,
Yeah.
"Hey, I got this alarm. What do I do?" You'll
No,
answer
they don't
the
call
phone.
me.
They don't call. Lee, are they going to call you?
They'll call me, but I will, there's not really much I can do to help them either.
All right. Sorry to interrupt. Go ahead, Lee.
Yeah, no, what's funny is I think communication is one of those things that when I work with my customers, we're like, yeah, we've got that part figured out. But I can tell you that doing the communications can almost take as long as anything else in the process. And so number one, I would recommend anyone who's implementing online monitoring of any kind outside of DGA is engage with your IT department as early as possible. And I know that sounds really tedious, but I can tell you that, many, many times where we've had a great implementation, customers see the value, but they just simply can't get the data back. And if you can't get the data back, then obviously a lot of the value of an online monitor is lost. And so you need to really take into consideration, as Senya has laid out already, is what do you have for hardwired networks? Is it copper? Is it fiber? What's available to you? Do you want to use some sort of mobile network? I know that some utilities are getting a bit more sophisticated in this. They even have their own mobile networks that they're operating on. But so rather than laying physical communication lines, they're just putting in modems. So having a monitor or a monitoring system that can be flexible to that is really important. And obviously we see fiber is kind of becoming the very much a standard for communication going forward. So be prepared for that as well.
I think this whole area of communication is a hot button right now, partly because the C-level people are saying, "Do not sell me a separate system that doesn't fit in with," and just by fitting into SCADA, you've now come using their existing system. But interoperability, integration of data, and since AI is going to depend on a lot of data streams, right? You're going to have AI generally on, hey, if this happens, then this is what you should do, which is going to be great because that's going to be collective. They're going to look at the entire monitoring situation wherever they can get the data. So the idea that we can take history and we can take large language models and we can actually simplify this through AI. If this happens, then consider this is what it's about. It kind of also creates better communication for the subject matter expert to be able to say, okay, your transformer's doing this. Transformers that do this tend to have this as a reaction, something that you're doing. So I think communication, especially with AI, is going to become more and more important. And I'm not even asking a question, but I am saying, is that true? Is that going to be the case?
Yes, that's a good question. I guess no one has correct answers, but there is a lot of discussion, a lot of speculation. I don't know how the AIs really work. Do they need data behind to be able to make any kind of a conclusions? Sometimes you see AI giving you very nice answers, but they tend to hallucinate also. So
Hallucinate. They ought to stop taking drugs.
yeah, for sure it will become. But again, these are extremely expensive assets, and as you Alan mentioned in the beginning, the lead times of new transformers are becoming longer and longer. I think it will take quite some time before people really trust on these machines
Yeah.
to make a full assessment. But definitely, they will be there to help.
So I'm going to challenge our audience because I'm going to do this. You know, the slide that you had that showed which one you should monitor, and it showed much more higher levels of hydrocarbons. I'm going to take that and put it in my chat GPT and say, which of these transformers should you monitor? Let's see what
Yes.
comes back with that. I
Yeah.
expect everybody to do that with your favorite AI model and maybe get
Yes.
back to us and find out
Yeah.
what you found out. That'd be good.
But I think the one important factor is the criticality. I mean,
Yeah.
in case of the failure, the consequences, and that is something I guess only the utility knows what's are the consequences, because they know the whole grid, and if certain transformer fails, what happens then.
Yeah.
But yeah,
Good.
we can only give like ideas and hints.
Okay.
So alarm limits. This is definitely a hot topic almost not every time, but let's say many times when talking with people who are starting online monitoring. And of course, if you have a monitor, you want it to give you a red flag when the gas levels increase, and then it comes to this, that what are my alarm limits, what limits should I put on for the relays to trigger the alarm for the control room. And there is no correct answer again on this. So how to establish meaningful threshold values so that they give value for the protection of the assets, and same time avoid getting false positives, so false alarms basically. People who work a lot with DGA, when you ask them or us, we tend to answer that define your own. And what does it mean is that that if you have a big fleet like grid operators usually have, is to put your whole fleet in there on the Excel sheet or spreadsheet or whatever database, and define what are the typical values of your transformers in your region, in your climate conditions, with your loading profiles, etc. And that probably will give much better, more valuable, kind of a more realistic values for the alarms. And but then again, many like power generation, they don't have so many transformers, and then it's again how to look at it. Okay, you can look like what is the existing levels and add like X percentage there, like let's say 20-25%, something like that, and define transformer by transformer, so specific transformer specific values for those alarms. Uh, a lot of people use standards, IEEE, IEC standards, where they have these typical values. The standards actually say specifically that these are not alarm values or limit values, but still people use them. And yes, it's kind of okay, but I would definitely still recommend to look at the existing levels of your transformers, because if we directly only apply uh, these values what are given in the standards, very often utilities say that actually the result come back like 50% our transformers are faulty status. And that is definitely not the case. If we look at the statistics, 0.5% is the failure rate of transformers. So that's why I, before like blindly following these typical values in standards, I definitely recommend to compare these values on your transformers' existing gas levels. And again, don't forget to have a process in place if the alarms comes up, not just the acknowledge the alarm and mute it.
Don't suddenly say, oops, what do we do now? We should
Exactly.
put a plan in place. Yeah, sure.
But we hear it a lot. People been disappointed of getting too many alarms, and I
Yeah,
think it's yes, it's because of the monitors behaving stupid or something. But I think many cases is that it's when you just follow the typical values in the standards, which doesn't take into account the use of the transformers. So that's why some transformers may have typically much higher levels, and again some transformers may have typically much lower levels. So that's why to really look at on your existing fleet.
excellent.
Over you, Lee.
Yeah, I wanted to put a fine point on what you just said there, Senya, which is that, you know, the standards are helpful. The standards can set kind of put you, you know, give you a value to start with, right? Values to start with, especially when you have a brand new transformer. But as we can see in this example of a transformer that we've looked at in the past, is there was some event. It has very high levels of acetylene, very high levels of ethylene. I mean, either one of these on their own would, you know, according to the standards, we should alarm and maybe look at this transformer. But when it comes to online monitors, this is where the value, I think, really shows is that trend, right? We can see that, you know, yes, they're very high, but they're very stable. And it gets to what you just mentioned as the use cases. Yeah, there may have been some event that caused this, but it's not ongoing. It's not an ongoing issue inside the transformer, and therefore, you know, it's not something we should ignore, but it's something that we don't need to take this transformer out of service. We don't need to, monitor it more closely. After, looking at this data, I think that, a customer can be much more confident that, they can get some more life out of this transformer. So this is absolutely like the number one question I get when talking with customers. What do I set my alarms to? And I have to give the absolute worst answer, which is it depends.
And they hate that, right? They hate
Everybody hates that answer, right? Everybody hates that answer. No, I don't want you to say it depends. I want you to give me some guidance. So yeah, the standards are there for a reason. It's not that they're bad. They're there for a reason, but as Sen has mentioned a couple of times, you need to take into consideration, the specifics of the transformer, the specifics of the use. And that's when you'll get to the levels that make sense for you.
Yeah, the answer to any question of it depends sends the questioner. But listen, I've got a lot of questions we're going to get to after you finish, but one of the ones that came up right now is it the same? Do we have limits, or do we have IEEE, IEC limits for the esters, synthetic and natural? Where does that stand in the hierarchy of limits?
In esters, basically the gases are the same. Depending, regardless whether you have mineral oil, natural ester, or synthetic ester, there is a little bit differences on what is the ratios, especially on thermal faults or thermal stresses. But for example, in some natural esters, we tend to have like naturally from the liquid some ethane forming without any fault. So the interpretation is a little bit different. Probably for some gases, we would put a little bit higher alarm level or the limit value because of this liquid's natural tendency of producing like ethane, but not so different than one could think of considering how different the liquids are.
Okay, good. Thank
But
you.
I think adding here what Lee said, this is a very good example, this ethylene here. So if considering the standards, the alarm or the typical value level would be somewhere like 90 ppm. So we would be continuously above it. But again, when looking at this specific gas of this specific transformer, if it's stable, we could add like plus 20%, plus 25%, and start from there.
Okay.
Yeah.
And the last part of is that now you have your monitor up and running, and there is all these integration to the systems and what to do with the data.
I see Michel
And
Duval here.
there is Michel Duval. I guess he's the most well-known, I would say, DGA guru. So he's done a really great job of making large databases into diagnostic tools. And I guess dual triangles is one of the most kind of accurate, having a best hit rate what comes to the result of the DGA diagnostics versus the actually found fault. None of these methods are 100% proof. DGA gives us an idea where to look at what's maybe ongoing. It can tell like, okay, it's a high temperature issue where only oil is involved, or high temperature issue where paper is involved. It can be partial discharging or so, but it never tells where it is. So other methods has to be used there. But what to do with the data when you have online monitoring? I guess a lot of people who have a larger fleet, if they don't get any alerts, they do nothing with the data, like on continuous base. They may have other systems calculating like health indices or so, where this system automatically collects the data and uses it for further analysis. But if you want to do it like manually, how you could do it is like, first of all, compare your DGA readings to your limit values, how close you are, is there a trend, increasing trend. You can compare the results to the similar transformers, like in my example earlier. You can check if there is an increase in some of the gases. Check if there is a correlation with the loading of the transformer, or the ambient temperature, or the oil temperature, and see if there is something you could identify where the gas may come. Oftentimes when people start online monitoring, they have these diagnostic tools there on the monitors, and then they are looking at these dual triangles and seeing if there is a fault. It's good to remember that these tools always give you a fault because they are based on gas ratios. So if you have 1 ppm ethane and 2 ppm ethylene and 5 ppm of hydrogen, and you start to use these tools, yes, you will get the fault. Of
Even
course,
if
it's
it
not
is
the
not a fault. Even if
yeah,
you're,
of course, it's not the fault. It's
yeah.
some gases are formed naturally in the transformer. So I used to say that I only use these tools if there is a reason to believe that there is a fault or thermal stress active.
Right.
So when you see clear gas increase and at least one of these gases is above your limit values, do nothing on the diagnostic base if the gas levels are low.
That is a critical thing that people often make mistakes on, is know your gas. It's the ratio. And as you said, 1 ppm, 2 ppm, that's a 50%, that's a doubling of the ratio, but it's not a fault situation. Yeah, that you
Yes.
have to very carefully use these tools with that in mind.
Yeah. So over to you, Liz.
Yeah, and what can be lost in some of these tools is is the time element, right? Is how quickly did we actually get to these values? And again, not that it doesn't make the tools that Sonia laid out any less important, but this is where, again, we've talked about a couple of times where online monitoring can, it shows its value is the trend is, in this particular example, we had it was a transformer that had, there was through faults coming in, and you could see that, it had already had high acetylene levels, which anyone on here who monitors transformers, right? 26 ppm is 27 ppm is very high, right? But more concerning is you could see this step up over a very short amount of time, right? So the time scale here is in days. So within 3-4 days, this was increasing almost 10 ppm over that time scale. So it sounds like a long time, but honestly, in relative terms, it's very quick. And so online monitors can really help you look at it in much more simpler terms of, okay, this is what the Duval triangle is telling me, or if you look at the pentagon, but how quickly are you getting there it can be just as important, or in some cases more important, because it actually doesn't matter what the values are. It's like they just keep going up, and they're going up very quickly. There's something very wrong here. So yeah, rates of change, alarms in your online monitor can be critical for situations like this.
Excellent. So you've done the 5 considerations, which transformer selections, the location and setup of the monitor itself. And I had a question on that came in, because we're going to try to answer a lot of questions. We're not going to get to all of them, I can tell. But your question will be answered, because we will send it to Senya and to Lee for them to maybe email it to different people. But one of them is not really much of a question as it is a statement. And then I would like you all to comment on it. Using specifically H2 hydrogen can present several issues if it is not accompanied by a rigorous methodology before implementation. That's the statement. And then it says, in the presence of stray gassing, in most cases, the gas generated is H2 hydrogen, but this does not represent a fault, but it can be interpreted as one, which may lead to an incorrect diagnosis. Is that statement true or false, and why?
I think it's true. It's really really true nowadays, especially with when we talk about mineral oils, highly refined oils with hydrogen cracking, things like that, what they use in the modern refining processes. With mineral oils, the typical stray gas is hydrogen. And yes, if you have a hydrogen monitor and you are not familiar with the stray gasings, definitely people think that, okay, is my transformer having PD, and concerns people. So yes, definitely that is the case. The stray gassing world is coming more complex, even with the new liquids on becoming more commonly used. There we have different stray gassing patterns. So we may have ethane, we may have methane together with carbon monoxide. So it will become even more and more difficult to identify stray gassing. Maybe the good thing to remember that stray gassing typically appear with new transformers, or if there's been like oil replacement or addition of some additives. But yeah,
Okay.
that's true.
I'm going to give you a couple of, or do you have anything to comment on that, Lee? Sorry.
No, I think Senya
Okay.
answered it completely and very well.
I'm gonna pitch a couple, because there's more on that one, but I want to get on the slide that you showed where the monitor was placed. It said, "Hi, I see an oil filtration system in the picture. Can I sample directly from the oil filtration unit?"
I wouldn't recommend that,
Okay.
only because it's really going to depend on the location
Right.
that you're pulling the sample from. And if you can pull from the main body of oil, that's always going to be much more preferred than getting into an oil filtration system, because
Yeah.
sometimes they can have, maybe, I think this one was focused on moisture, but some can have, let's say, the ability to outgas a bit. So you may not be capturing the trends correctly in particular if that's the case.
Okay.
Yeah, I think this is a very good point that it may the system may affect on the gas levels, and kind of
Right. May have
you are not
filtered out.
seeing the real situation in the tank.
All right. Another yes or no kind of answer. Can the unit be mounted directly against the transformer, or will the vibration affect the performance? I think this picture is showing it mounted on the transformer, if I'm not mistaken.
Yeah, can be installed in. We do have like vibration dampers available for such installation. OEMs, especially when it's question of new transformer, they make readily available the installation kind of a frame there.
Okay. Another yes or no kind of question. I like these ones because we can get through them. Is there a need for a recalibration for the oil sensor? What is the required interval of recalibration?
You want to take this, Lee?
Yeah, so in our particular case, no, we don't require any calibration. We actually have that. We have that as part of our normal, let's say, sampling process, is actually to basically calibrate the device. I won't go into all the nitty-gritty details on that, but in our case, it's built in. Some other devices, they do require calibration after some period of time, and that can be either some certain number of cycles or some specific period of time. So I think it all depends on the monitor that you have.
I can tell you from practical experience for my years in the industry, um, the number of times where for a monitor that needed calibration, it's people don't do it. I mean, they don't realize it because guess what? The person that bought the monitor that knows about it has retired. And now when you say, hey, you got to recalibrate, is the data you're getting because it's not calibrated, or is the data you're getting real? And that becomes a big issue because that's where you get the false alarm of, hey, it shows that there's a problem. You recalibrate the monitor, and guess what? You don't have a problem anymore.
Yeah,
That's a
think
big
Yeah.
issue.
yeah,
Sorry.
I think this is a topic which varies a lot by manufacturers, and the only way to really get in deep into that is to talk with the monitor manufacturers and ask them to describe how they handle the long-term stability of the devices.
This next question, I think we've answered, but I like the way it's poised, and this comes from Dorothy Main. Thank you, Dorothy. There are many tools which can provide trending, but with so many assets to look after, and by the way, I'll add to her question, so many different assets from different manufacturers, so different transformers. There's no one standard out there. You just see, you still see a lot of Westinghouses made in the 1970s that are still operating and are going to continue to operate versus something new. But what actions are there tools which recommend what actions to take? This could help us allocate limited resources more effectively. I guess this goes back to the subject matter experts, but also to the Duval triangles and pentagram. But are there other tools out there? Do IEEE or IEC offer any?
If you have a bigger fleet or you are in contact with other utilities who have similar transformers, similar kind of a operation like transmission, for example, I would start with looking at what is the 90 percentile of the gas values of my fleet, or 95. And again, keeping in mind that the average statistical failure rate is 0.5%. 95%.
Yeah.
So if you look at your whole fleet, let's say you have 100 units and you took that 95% percentile, you look at your top 5% that has the highest levels or most kind of a different, then you can focus on those. That's my kind of a general recommendation how to look at that. And then if there is a clear indication, like for example, Lee was showing this example where the acetylene was quickly increasing, you may want to use some electrical offline methods to understand where this comes from.
Okay. I think this also, what you just answered, and Lee, do you have anything to add to that?
The only thing I would add is that you know, there's many levels of sophistication that you can get into these days, I think, when it comes to data interpretation. So it, you know, can start with Duval triangles, you can look at trend analysis, and then there's even more sophisticated tools out there as well. So I think it's all, as Senya said, you know, having a plan in place is really important. And, you know, how you're, you know, what are the assets you want to monitor, how you're going to monitor them, and then what's the plan, you know, for what you will do if, you know, one of those alarms is triggered.
Okay.
Yeah.
The next one I think is specific to Vaisala, but what is the recommended sample frequency for the OPT 100? And if a short interval is selected, will this affect the expected life of the analyzer? Is OPT 100 unique to what is that?
Over to you, Lee.
Yeah. So the OPT 100 is our multi-gas system. I promise I didn't plant that question.
No, I can say Hank put that question in there. So if you know
Yeah.
Hank. Yeah.
So it's yeah, so we've obviously it's been pictured here. You can see the device, but so this is our multi-gas monitor, and what is unique actually is our sampling rate is basically fixed. So we sample, I would say on average, it's about 80 minutes is when you get a data point. And there's what's really cool about the design of the device is that even with a sampling frequency that high, we're not cycle limited in any way. So none of the components are limited by that or need to be replaced after some, you know, number of cycles or some amount of time.
Excellent. So this next question, I'm not sure how this happened, but it may be our last one because I want you to comment on this. And this is from Cobus, and he says, we are using the OPT 100, and on 2 occasions, the rate of change alarmed us to prevent catastrophic failure due to the fact that we could set the sample rate to every hour. Is that a good practice to set the sample rate at every hour, or is that something that?
Yeah, it is basically fixed. It's the unit defines itself what is the sampling rate, because it's basically affected by the oil viscosity, which is basically the temperature of the transformer, the amount of gases, because we are dissolving the gases back into oil, so that may take some time. So the more gases there are in the transformer, it takes longer to dissolve them back. So it is really designed that the operator don't need to do anything. In best case, it's like install and forget until it traces the flag like, hello, I'm here. There is something going on.
Yeah.
There are more questions, but we've come to the time limit for our webinar. I appreciate, and by the way, this is a blatant commercial for the October issue of Transformer Technology. We actually have an article in there that talks about setting your own health index, because I think you mentioned the health indices, Senya. So if you pull that October, you'll find that article and it'll give you some insight on that. Senya, Leovo, as usual, I love it. Lee, it's good to meet you and thank you for doing this. This has been an APC Media presentation. Thank you both very much. Here we go.